In this video, I'd like to continue talking about finding the distance between two complex numbers. And one general strategy is that we can plot both of these points on the complex plane. We can then draw a line between them and figure out the distance or the length of that line. So let's apply that strategy. Let me first paste in a copy of the complex plane, and then we can plot both these points. And for this problem, we can use a scale of 2 for both the real axes and the imaginary axes, so 2, 4, 6, 8, and so on. And for the imaginary axes, this would be 4i, 6i, and so on. And let's start by plotting z1. We can do that in this green color. It has a real part of 8, which is right here, and an imaginary part of 3i, so z1 would be right here. And for z2, we can do that in orange. It has a real part of 5 and an imaginary part of negative 7i. So we go down to right about here. And again, this is for z2. Now we can connect both of these points with a line. And we essentially just need to figure out what the length of this line is. So we can call this line d for distance. And the strategy at this point is to decompose this into a right triangle. And once we have a right triangle, then we can use the Pythagorean Theorem to relate the two legs of the triangle to this distance d. And at this point, we just need to drop a vertical line that's perpendicular to the real axis, and then connect that to a horizontal line going to point z2 that is parallel to the real axis. So let's drop that vertical line now. It starts with an imaginary value of 3i, which is related to z1, and goes down to an imaginary value of minus 7i, which is the value at z2. Then we draw a horizontal line, which from here starts at a real value of 8 and goes to a real value of 5, which is the real part of z2. And again, this creates a right triangle. These two segments are perpendicular to each other. And we now just need to figure out what the lengths of these segments are. So let's start with this horizontal component here. And we need to find the difference between the real parts. Since this has a real part of 8 and this has a real part of 5, we can find that this length is 3. But we can think about it as finding the absolute value of the difference between the points. So we can do 8 minus 5. This is the real part of z1, and we're subtracting the real part of z2. Or we could do it in reverse. We can find the absolute value of the real part of z2 minus the real part of z1. Since in either case, we find that this is equal to 3, since the absolute value of a negative number is positive. So we can apply that same idea to the vertical component here. We just need to find the absolute value of the difference between the imaginary parts, and we can ignore I at this point. We really just want to find the magnitude of this line. And the imaginary part of z1 is at 3i, and we will find the difference between that and the imaginary part of z2, which is at minus 7i. And since we're subtracting a negative, we're really just adding 7 to 3, and we can find that this is equal to 10. But if we did this the other way, let me just make a little bit more room, we would find the same answer. We would start at the imaginary part of z2, which is minus 7, and find the difference between that and the imaginary part of z1, which is at 3, and you see that this would simplify to the absolute value of negative 10, which of course is positive 10. So one general strategy that we'll explore further in the next video is to find the absolute value of the difference between the imaginary parts and do the same thing for the real parts. And we will use those values to construct this right triangle. And from here, we can figure out what this distance d is by using the Pythagorean theorem. Since now we know this is length 10 and this is length 3, And we know for right triangles that a squared plus b squared is c squared, where a and b, these are the legs of the triangle, and c is the hypotenuse. So we can label a as either 3 or 10, it doesn't matter. So let's say this is 3 squared, and b would be 10, so we have plus 10 squared, and this is equal to the hypotenuse squared, and we call the hypotenuse d, so we have d squared. And 3 times 3, that's 9. 10 times 10 is 100, so we get d squared here, and after simplifying, d squared is 109. And lastly, we just need to take a square root of each side to cancel out the square. So that d is the square root of 109, and this number here is a prime number, so we cannot simplify the square root any further, so this would be our fully simplified final answer. And in the next video, we will look at a formula using the difference of the imaginary parts and the difference of the real parts in setting up this right triangle here. But in the formula, after we derive it, we won't need to draw a picture every time we want to find the distance between two complex numbers. We can just use that distance formula. And it looks very similar to the usual distance formula, but with some slight modifications.